Hi everybody, my name is Sean O'Kane with Chip Estimate TV. We're here at the TSMC OIP Forum 2011 in San Jose, California. My guest today is Kevin Kranen, Director of Strategic Alliances with Synopsys. Thank you very much for joining us today.
Thanks for having me.
All right. Yeah. So Synopsys has had a long-standing collaboration with TSMC to provide designers with IP, tools, design flows, and process technologies. Does participating in the OIP stimulate innovation?
Well, first, just a bit of history.
Yeah.
I mean, we've been working with TSMC for maybe 10 years, a little bit more than a decade, and helped pioneer the first reference flow with them. Now remember, that was back when Synopsys was just kind of a synthesis company, right. Synthesis, test, and simulation. At that point in time, that was kind of the kickoff point, because one of the goals was to bring it all together with routing companies, analog mixed signal, IP.
Right.
So, you know, today it's become a very structural way of doing this innovation. OIP brings a structure to moving to the next node and all the things you have to do in order to enable the node from a tool, right. from an IP, from a flow, and even from getting the best out of that node perspective.
Mm-hmm. Well, Art Tagias is presenting in a general session, and the topic is what's driving the need for collaboration. So because process nodes are getting more, smaller and increasing demands for power and performance, is collaboration more important now than ever?
It is more important, because if you think about it, I mean, you talk about performance and power, but there's also what? Complexity. Mm-hmm. There's also the whole notion of, the physics. Mm-hmm. Well, maybe the physics isn't changing, but it's more strictly enforced at 20 nanometer. And then you throw in, the third piece, which is kind of time to market.
Right.
All the people who want to move to a new node are the guys who want time to market. They want the performance, they want the power, and the physics is still as unyielding as ever.
Exactly.
So it really is about mating those two things together, solving the customer's needs, mm-hmm. and solving it in the context of the physics that keeps twisting our arm at the other end from an EDA and IP and flow perspective.
So you think there's a strong ROI associated with participating in OIP?
I don't look at it in terms of ROI. I think about it in terms of really just pure enablement. We wouldn't be able to work with those early customers. I think, Art's talked about it before, might talk about it in the future, but we're really, TSMC is running a $6 billion restaurant operation. Yes. Where you got to deliver the food all on time with a high level of quality, and you got to organize all the cooks in the kitchen if you're ever even going to deliver that, let alone make money on it. Yeah. In our game, it's all about being able to deliver that customer experience that allows high yield, right. allows the density, complexity, low power, high performance that they need, and you got to start working ahead of time on that.
Exactly. Early design exploration and then collaboration. So talk about the Synopsys' open transactional level modeling. That's the TLM 2.0, which is fairly recent, the library that was released. And how does that help TSMC and your customers?
Well, you kind of have to start at how people look at designs at the high level. They want to model things, they want to try things out. And for a long time, Synopsys has actually been in the virtual platform business, have a product virtualizer. But the real key is, in order to make that work and be able to do the design trade-offs at a very high level with software, mm-hmm. you've got to have all the models there. And TLM Central is about providing a repository for models and kind of a trading post for models, mm-hmm. So that people can assemble these virtual platforms. Now, if you're able to assemble a virtual platform, you're able to instrument it, and TSMC has taken some initial steps in instrumenting those virtual platforms. Mm-hmm. They have something called IPPA, which is a way of modeling performance, power, and area with real TSMC process data and bringing it all the way up to the system level. So if you can have a virtual platform with all the models, mm-hmm. and you also have all the technology information, you can do much more intelligent trade-offs. And again, I'm talking about trade-offs with software, with hardware, before you ever build and design the final hardware.
Right. Well, that absolutely makes sense, So anyway, thank you very, very much for joining us today.
You're welcome.
I appreciate taking the time, and thank you. And join us on another episode of Chip Estimate TV. My name is Sean O'Kane. We'll see you next time.